In the introductory video on symmetry, we learned about axis of symmetry or the line of symmetry. Okay. We learned this term, and this discussion will be using this term. Okay. We are going to base our discussion on axis of symmetry. If we have this figure, okay, and if I ask you that is this figure symmetrical, you will say yes, of course it's symmetrical, and it's the same figure that we took in our first video, that is the introductory video on symmetry. And if I say that if I pass a line exactly from the center, okay, let me try again. Okay, just assume that it's passing exactly from the center, okay, though it's not very accurate, but just assume, and dividing this into two equal halves, that is in symmetry, and this is what? The axis of symmetry. If I ask you that is there any other axis of symmetry possible in this figure, just look at this one. This is one axis of symmetry. Do we have any other? Can we draw something like this? Can we pass a line from this, thinking that this line is dividing this figure into two equal halves such that the two halves are mirror images of each other? No, it's not a mirror image, because this is the head and this is the, the leg portion or the feet portion. So no way that it can be symmetry. So in this figure, there is only and only one axis of symmetry possible. Only one axis of symmetry possible. And in this video, we are going to discuss this thing only, that in a given figure, how many axes of symmetries are possible. Let's take this one and let's imagine that this is our axis of symmetry. Really sorry. Okay, if this is the axis of symmetry, and let's suppose that this is the center. Let's suppose that this is the center. Okay, if this is the axis of symmetry, why? Because it's dividing this figure into two equal halves, and two equal halves are mirror images of each other. Therefore, this figure is symmetrical around this axis of symmetry. Now, if I ask you that are there any other axis of symmetries possible in this figure, you will say that yes, of course it's possible, because if this is the center and if I pass another diameter line from the center, let me take with some different color in this case. Okay, this one will also be the axis of symmetry. Why? Because it's again passing from the center. It is a circle. Now, those of you who have learned about circle, who have learned about diameter, know that diameter always passes through the center, and diameter will always divide circle into two semicircles, right? You remember that. So if this line, that is the axis of symmetry, is passing from the center, therefore, of course, it will be overlapping the diameter, and therefore we will again get two equal halves. Okay, now we have two axes of symmetry till now. Why I'm saying till now? Because you can have more than two axes of symmetry. How? Pass another line from this center. Okay, so now we have three. Okay, I'm not going to stop here, because I'm going to pass another axis of symmetry, because now this will divide into this two equal halves. Okay, this one, just focus on this line. Just focus on this line and forget all the other lines. Now, if this line is at your focus, then you'll think of this equal part and this equal part. Okay, now we have 4. Can we have more? Yes, of course, because it is a center, it is a circle, and it will have more and more many axes of symmetry. Now we can have axis of symmetry around this line. So this is the fifth one. Just focus on this line, axis of symmetry, or the line of symmetry. Just forget about all these lines. And if you are thinking of this line, then this part and this part will be the mirror images of each other. In this way, we can have n number of axes of symmetries in the case of circle. Okay, this was not possible in this case. In this case we had only one axis of symmetry, but in this case we have many axes of symmetries possible. What about, I'm sorry for this one, just give me a second. Okay, what about this figure? You will say that, hey, you know what, we can have, this is a square. Okay, this is a square. This is a square. And you will say that, hey, you know what? This is one axis of symmetry that is passing exactly from the centers, that is midpoint of this side and this side. So this will divide this part equal half and this equal half. Both are mirror images of each other, therefore this will be one axis of symmetry, right? But we can have another one, because if we pass a line from the midpoints of these two opposite sides, if this is the midpoint, if this is the midpoint of these two sides, then this is another axis of symmetry, because now just forget about this line, just focus on this one. We have these two equal opposite mirror images of each other, and this square will be symmetrical around this axis of symmetry. Therefore we have two axes of symmetries in this case. Okay, what about this one? What about this one? So in this case it is a rectangle. In this case we have a rectangle. In this case we have a rectangle, and if this is the length, right, these are the lengths. Now these two sides represent length. Then if we take a line that is passing exactly from the midpoints of these two opposite sides, that is the length of this rectangle, then this will be the one axis of symmetry, the first one, because it will divide the figure into these two equal halves, and these will be mirror images of each other. Therefore this will be the one axis of symmetry. Now similar to what we did in the case of square, if we draw another line passing from the midpoints of these two opposite sides, then this will be the another axis of symmetry. Just forget about this line and focus at this one. If you focus at this one, then this is one part and this is another part. Both these two half parts are mirror images of each other. Therefore this figure is symmetrical around this axis of symmetry too. This is one axis of symmetry, this is another axis of symmetry. So in this case we have two axes of symmetries. What about this one? So it's something like square, though the edges are somewhat rounded, but all the sides are equal, not exactly square, but all the sides are equal, only edges have been rounded. So in this case, again, similar what we did in the case of square, one axis of symmetry will be along this side and another one will be along this side, right? So again we have two axes of symmetries, two axes of symmetry. Okay, I'm really sorry for this one. I don't know how I missed this to correct in my presentation. Anyways, so even in this case we'll have two axes of symmetries. one will be along this one, and one will be along this one. Okay, so again, two axes of symmetries. What about this one? Now this is an equilateral triangle. It's an equilateral triangle. And if you look at this equilateral triangle and take this vertex, if I pass a line from this vertex and that passes exactly from the midpoint of this side of this triangle, of this equilateral triangle, then this will be one axis of symmetry because it's dividing this triangle into two equal halves. Similarly, if we take this vertex and if we pass a line from this vertex that passes exactly, suppose that excuse me, this is the midpoint of this side, and from this vertex to this midpoint a line passes, it will also divide this triangle into two equal halves, that is mirror images of each other. Therefore this will be another axis of symmetry. Now similarly, if we take this vertex and if we try to pass a line from the midpoint of this side of the triangle, then this will be another axis of symmetry. Why? Because just forget this line and this line, focus on this line, and if you focus on this line, now this triangle has been divided into two equal halves that are mirror images of each other. Therefore this triangle will be symmetrical around this axis of symmetry. Therefore in this case we have three axes of symmetries, and in this case we have many axes of symmetries. So if you have more than two axes of symmetries, if you have more than two axes of symmetry, I'm really very sorry, I use axis of symmetries, I'm sorry for that, it's axis of symmetry. If you have more than two axes of symmetry, then that figure will be called having multiple axes of symmetry, I should have not used axis of symmetries, that was wrong. So if you have more than two axes of symmetry, then that will be actually multiple, that figure will be having multiple axes of symmetry, like in this case and like in this case. In this case we have three, and that is greater than two. Rest all, this was only having one, but in this case we have two, in this case we had two, and in this case we had two, in this case we had two, and in this case we had three. Okay, so this was all about, having one axis of symmetry, having two axes of symmetry, and if you are having more than two, then that will be called a figure having multiple axes of symmetry.